All right, so this is going to be problem number 2 on the high-level rational function sheet. I'm going to jump right into it and see what we've got here. So I want to see if I can factor and cancel. So let's see. Factoring this numerator, let's see, x minus 4x plus 1 all over x minus 3. All right, so nothing cancels. All right, good to know. So we know there's no discontinuities. So I'm actually going to mark that there are no holes in the graph. All right. For the x-intercept, you need to take the numerator, and there are 2 factors in the numerator. So take each factor, set it equal to 0. So we're going to have x-intercepts of positive 4, 0, and negative 1, 0. 2 x-intercepts in this case. Y-intercept. Take the function. There's no simplified version, so take the function, set x equal to 0, and solve for y. So 0 squared minus 3 times 0 minus 4 all over 0 minus 3. So this is going to turn into negative 4 over negative 3, which would just be 4 over 3. So 0, 4/3. Okay, vertical asymptote. Take the denominator, set it equal to 0. We're going to have a vertical asymptote at x is equal to 3. Now, do we have horizontal or do we have other? And we want to look at the degree. So I have a second degree polynomial in the numerator, a first degree polynomial in the denominator, higher degrees in the numerator, which means I have some kind of other asymptote. In this case, it's going to be oblique because the degree difference is just 1. So horizontal is none. Now, how am I going to find that oblique asymptote? I am going to do synthetic division. So I'm going to take the x minus 3 that I'm dividing by, and I'm going to use positive 3 in the synthetic division. And I want the coefficients of that second degree polynomial in the numerator. So coefficient of x squared is 1, coefficient of x is negative 3, constant is negative 4. Little workspace here, drop, multiply, add, multiply, add. All right, so this tells me, remember this last term on the right is your remainder, the constant, and then this is going to be x to the first. So if I translate this into something that's actually usable other than 1, 0, and negative 4, our oblique asymptote is going to be y is equal to x. Let's run 1x. And then 0 is the constant, so plus 0, well, I don't need to write that. And the remainder never matters when we're dealing with the oblique asymptotes or any other asymptotes. All right, lots of information to get on the graph. Let's go ahead and slide on down and start graphing this. So 4 and negative 1 are my x-intercepts. So positive 4 here, negative 1 here. 0, 4/3. It's a little bit greater than 1. And I had a vertical asymptote. I'm going to go ahead and put that in blue, but I want to narrow down the line. Vertical asymptote was at x is equal to 3. And I had the other asymptote. In this case, that is oblique. Oblique asymptote is y is equal to x. So if you remember how to graph a line, y is equal to x has a intercept of 0. And a slope of 1. So from the origin, I'm going to go through the origin and then just count 1, 1 up and to the right, and then down 1 and to the left 1. There we go. All right. So that's the 2 asymptotes put in place, and we actually have enough information to graph this, because I know I have from the vertical asymptote's the one that's going to tell me my 2 sides. So if I look to the right of the vertical asymptote, I have this point right here, this x-intercept. And then if I look to the left of my vertical asymptote, I have these 2 points right here. So it's going to look a little strange. All right. So you are going to, I'm going to start with 4 first. So I'm going to curve up from 4 towards my oblique asymptote here, and then just start kind of trailing around it. And then I'm going to curve it down towards this vertical asymptote. Never cross it, but get close. Okay, so that's one half of the curve. And then the other half, I'm going to start with -1, go through the y-intercept. This is going to curve up towards your horizontal, sorry, that's a vertical asymptote. And then curve down and approach this oblique asymptote. Now remember, when you look at this graph, the green curves are the actual curves of the graph, not the blue dotted lines. All right, so the green is the actual curve. The blue dotted lines are the asymptotes to help us graph it. Okay, so that's going to be the end of this video. Send me any questions or comments or any concerns that you have so that I can help you out with these.